Hello, welcome to part 3 of a series on factoring quadratic trinomials. In this example, just like the last example, we have a lead coefficient of 3 in this case. Now, in the last example that we did, part 2, we realized that the lead coefficient was 3, but that 3 was a common factor in all three terms. Now here, 3 is not a common factor. 3 does not go into 5. It goes into 12, but it needs to be a common factor. It needs to be common in all three terms for us to be able to factor it out. So here we can. So how do we proceed from here? Well, the first thing that we do is we actually answer the same questions that we've been answering for all three, or all the situations with regards to factoring a trinomial quadratic, and that is, what two numbers multiply together to give me a times c, which in this case is negative 36, and which two numbers add together to give me 5. Now, negative 36. Negative 36, there's a lot of options to multiply two numbers to get negative 36. So off to the side, I'm actually going to go ahead and list some of them. Now, as I list them here, I'm going to ignore just for a moment that this is a negative 36 and just think of ways to multiply together to give me positive 36. So 1 times 18, or 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. And I think that might be it as kind of the options of getting 36. Now I ignored the negative for a moment because it basically comes down to that either the first number in my column here has to be negative or the second number has to be negative. And it could be either or to give me negative 36. So I'm just going to visualize what option would then add together to give me 5. And right now I'm drawn to this 4 and this 9 because they differ by 5. So if I set this up right and think to get a positive 5, I would need a 9 and a negative 4, that also multiplies together to give me negative 36. Okay, so the first step is the same as what we've been doing when there wasn't a lead coefficient. Actually, the next step is also the same. We write two linear factors, or binomials. These aren't factors yet. We're going to have to tweak them a little bit. X plus 9 and x minus 4. But yeah, these are not factors. They're just kind of some intermediate binomials that will help us get to our factors. So what do we do with these? Well, the first thing we do is we take the lead coefficient and we divide both of these constant terms in the binomials by the lead coefficient. And if possible, we reduce. And if we're able to reduce, then this binomial is a factor of our original quadratic. Now what if we can't reduce? Well, this technique, it's a little bit of a trick that we use, and the purpose of using a trick is to make this quick and as fast as possible, because factoring itself is just a tool that we use for other things. But what we do is we take the lead coefficient that we've divided by, and if we can't reduce, we bring it up in front of the x in that factor and rewrite that binomial as 3x minus 4. So whenever there's a fraction, we either want to reduce it, or if we can't reduce it all the way, we're going to take the denominator and move it up in front of the x. These two binomials are our answers. We could check that. We could, FOIL x times 3x and get 3x squared. X and a negative 4 would give us negative 4x. 3 times 3x would give us 9x. Those terms would add together to give us 5x. And then 3 times negative 4 would be negative 12. So I hope you can check back later as we talk a little bit more about quadratics.